In this example, it says, do the needs of patients in the emergency room differ for those who come by car versus those who come by ambulance? Okay, so you're understanding what that question is saying. So if you're a nurse or a doctor working in the emergency room at a hospital, and you see somebody coming into the emergency room by car, like they drove themselves there or were driven by somebody there, or by ambulance, do you think they're going to tend to have different needs? Of course, huh? Right? Somebody come by ambulance is going to have probably a more serious, immediate need than somebody who comes in by car, probably typically on average, right? Well, let's let some data. This is how hospitals would try to decide things like this. Let's let some data drive our thinking. Of the randomly selected emergency room patients who came by car, so they had a bunch of people that came in by car, and they randomly surveyed them. 69 had some kind of injury, 48 were sick, 50 had heart problems, and 57 had other needs. And then they randomly selected some emergency rooms who came in by ambulance. They took a bunch of them. 50 had injury, 29 were sick, 57 had heart problems, and 36 had other needs. So let's conduct an appropriate study to test if the needs are different or not, right? Do the needs of patients in the emergency differ, those who come by car versus those who come by ambulance? Are they different? First off, what is the correct statistical test? It's homogeneity. You can tell the answer right there. How would you know that if the answer wasn't sitting there staring you in the face? Well, it's because we have two groups. Do you see that we have two groups? Um, come by car, come by ambulance, right? It's those coming by car or ambulance. Those are the two different groups. So whenever you have two, and we have two groups or two samples, right? It says, right, randomly selected people who come by car, blah, 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 blah. And then it says, and then it says randomly selected people that come by ambulance. So we had two different samples. So if you go back to the notes, here's the Unit 4 notes. It's going to be test homogeneity because right here, see this test to see if two different samples have the same distribution. That's how we know it's homogeneous. Homo means same, right? Homo is same. So homogeneity test, the genus means population. So same population. You're testing to see if two different groups or samples are really the same makeup, right? Are the people coming in by car, by ambulance, do they have the same kind of needs, like same amount of heart troubles, injuries, sicknesses, and other things? Or are they different? So whenever you're seeing if two groups are the same or different, that's a test for homogeneity. It's not up, you think, well, how do you know it's not goodness of fit? Well, goodness of fit is one of two types. First type, equal distribution or same frequency, meaning are they all the same? Like same number of heart patients, people sick, is every category exactly the same? That's not what we're testing. That's not what they asked. Is do we have the same number of injuries, heart patients, a sickness, they all exactly the same. No, that's not what they're doing. Or if they give you category percentages. They didn't give us category percentages. They just gave us numbers in from a sample survey. And they say, okay, yeah, so it's not that. How about test for independence? Well, there's test only one sample, just one sample, not two different groups. We had two different groups, those who came by car and those who came by ambulance, right? Car and ambulance. We're seeing if they have the same kind of needs or not, if two different samples are the same or not. That's test for homogeneity. So that's where we're at. Test for homogeneity. Okay, so what's the null? What's the alternative hypothesis? Null is HO, alternative is H1. What are they? Well, you can tell right here. Once you know it's test for homogeneity, it says right here, HO, the two variables, the two groups, two samples are the same. H1 is they're different, same and different. So we go, oh, okay, okay. So HO is same. See, that's HO, same. And H1 is not the same. There we go. HO, H1. Same, different, or same, not same. That's right, different. Same thing there, right? All right. And then next, time for C and D, the test statistic and the p-value. Where do we go? You know where we go, the online calculator. So I'm going to go to the online calculator. Which one? Homogeneity says right here, online calculator, test for homogeneity. No big surprise there. So here we go. Test for homogeneity is it's 23. See it down there? 23, test for homogeneity. 23, we go there. And when we go there, what we get is a couple of columns, A and B. And we have to put the data down A and B. So if you go back and see the data, here's the data. So I'm going to take these numbers right here, 69, 48. So this is 69, 48, 50, and 57. Oops. Put back there. 50 and 57. That's all going to be A, because those are the people that came by car. Those are the car people and how their needs spread out. And then we have the ambulance people. 50 had an injury, 29 were sick. So 50, 29, 57 had heart, and 36 other. And that's B. That's the ambulance people. So we're going to put those down A and B and hit the calculate button. Let's do it. So come on up here. You just got to type in. You can't really copy paste because the calculator, unfortunately, the boxes go down instead of across. Not sure why Mr. Green made it that way, but it'll be all right. We'll make it work. He probably had a good reason. He's a lot smarter than me and a hard worker. Let's see. There we go. There's the numbers. Hit calculate. See what I did there? I just put the numbers in there, right? Just write down A and write down B. A is the people that came in by car. B is people that came by ambulance. Hit the calculate button. There's the chi-squared. That x-squared is called chi-squared. And the p-value 0.1022 or 23, I guess it'll round to. Come on back. Yep, that's right. This is the, it looks like an x-squared. It's called chi-squared. It's a Greek symbol. I'm not going to test you on that. There's the p-value. That's the one we really care about, 1023. It's like we saw there. All right. Time to draw some important conclusions about this matter. So the p-value, 0.1023. How's that compare to alpha? What was alpha? Right there. Alpha is 0.01. Which one's bigger? Well, if you're not sure, line them up. So 0.1023 and point, meaning line up decimal right over decimal. And then the blanks, fill in zeros in the blanks. And then it'll be easy to tell which one's bigger, 1,023 or 100? Certainly 1,023 is bigger, greater, right? On the wide side. This one's bigger. He's on the wide side of the symbol. All right, so that one's bigger. So, all right, so now what is our saying? If the P is low, then the HO, the null, must go, meaning go away. So if the P is low, how's it go? If P is low, the null must go away. Is our P low? Our P value low? No, it's greater, right? The P value here is greater. Greater. So not low. Our P value is greater. It's not low. It's greater. So then I got to go back here and put a not on this. P value is not low. The HO must not go away. So in our case, the null must not go away. So the HO, we fail to reject, right? It's not going away. We're not rejecting it. In fact, we're going to keep the null, aren't we? Right? If the P is low, the null must go. If the P is not low, our P is greater, it's not low, then the null must not go away. Don't reject the null. Fail to reject the null. That's what I put here. Fail to reject the null. Keep the null. Keep the null. Okay, and then that helps us know which one of these 8 options is our conclusion. Keep the null. So let's go back to the null. Now remember, every null is weak evidence, isn't it? Every HO is weak evidence. Every H1 is strong evidence. So what are we doing then? We are, let's trace it back up. We're keeping the null. So I'm going to go up here. Just keep on trucking up. So I'm right here. I'm going to keep the null. So weak evidence and same. We're saying the people that come by car or by ambulance are pretty much the same. Doesn't seem like there's a big difference between the groups. That's our conclusion. Why? Because the evidence is just too weak. There really isn't evidence, not strong evidence, of a big difference. There's not strong evidence of a big difference, at least in these 2 samples, between people come by car and people come by ambulance. So our conclusion is the evidence is weak, and we're just going to stick with, hey, they're pretty much the same kind of needs for people who come by car or by ambulance. How did we decide that? Well, because the p-value was greater. It was not low. If the p is not low, the HO must not go away. Keep the HO. keep it. And we go back to HO, and HO says weak evidence, same. The two groups are the same. Car and ambulance needs are the same. Let's go find that option now. So is it going to be sufficient or insufficient? Well, let me write it right here. It's weak evidence. What does that mean, weak evidence? That means insufficient. Insufficient means not enough, right? If something is insufficient, it's not enough. You write a bad check, you write a check and there's not that amount of money in your bank account, they'll say insufficient funds. It means not enough. Not enough evidence, right? Insufficient evidence, not enough evidence. Okay. So, all right. So we don't want these. So cross out these ones that say these are all wrong. We eliminate 4 of them right off the bat. So now we're down to the other 4 that say insufficient. Which one is it? Well, here's one that says is the same. Insufficient, same. That must be ours. No, actually, it's this one. It's insufficient, not the same. That's our answer. Now, why? You might think, wait, mister, you said up here, HO, we want is the same, right? That's what we conclude they're the same. Yeah, but they're saying a negative word. They're saying there's not enough evidence to conclude car and ambulance are not the same. So we conclude they are the same. They don't put that last part on there, but that's what it means. Are you tracking with me? It's a double negative, you see? It says there's insufficient evidence to conclude that they're not the same. There was not enough evidence to conclude they're not the same, so we conclude they are the same. And that's right. We are concluding they're the same. That's what HO said. The two groups are the same. But it's tricky. You've got to say there's because they used a negative. It'd be like if I said, I did not skip class. That's a double negative. So therefore, I was at class, right? A double negative goes back to positive, right? There was not enough evidence. There was insufficient evidence to conclude that they're not the same. Therefore, they are the same. That's right. Not enough evidence that they're not the same. That fits with our conclusion that they really are the same. A little tricky on the ending there. There we go.